So for this worksheet, there's a little bit at the top that says, in some problems below, and hint, hint, also worksheet 32, you might want to use the following. And so I want to show you why this is true, to show you that you already know how to prove this binomial series, okay? So if you notice, first of all, we usually think of k as being a positive constant, but it does not have to be. Okay, so is equal to what? Let's figure this out. Okay, so this is f, and whatever k is a constant that's not 0. So f of 0 is just 1. F prime of x is the k is gonna drop down, and then you get k minus 1. So f prime of 0 is just gonna be k. F double prime of the function is gonna drop down k minus 1. And so the second derivative at 0 is just going to be k times k minus 1. And hopefully you can see the pattern here. So it's going to look like this. 1 plus k plus kx rather, plus k times k minus 1 over 2 factorial, which is 2, plus k times k minus 1 times k minus 2 over 6, otherwise known as 3 factorial, and so on and so forth. So hopefully that makes sense to you. And generically, we can look at it this way. F of x is, and let's look at what does it look like, what does it look like in a summation? So it's always going to be like this for your Taylor-Maclaurin series, x to the n over n factorial. Okay, so this piece right here is going to be your k minus 1, k minus 2, all the way up to k minus whatever, okay, I, but not all the way up to minus I. Okay, maybe it is. Let me see. Hold on a second. Nope, it's off by 1. So you go all the way up to I minus 1. You keep doing k minus, k minus, k minus, all the way up to almost I, and that's the piece that goes in here. Okay, and so there you have it. And now you can use it, add it to your lookup list, add it to your lookup things, and then you're good to go. And you will use it in question 1C, and I think it features in video 32, homework 32. And again, we never presumed that k is equal to something like 4. K could equal to 1/2. K could equal to minus 1/2. Anything you like. Okay, now you have a question that looks something like this. I'm going to make up something that's similar, not identical. Now, here's the thing. Don't fall for this. Don't fall for it. You're not going to divide by e to the 3x. That's ridiculous. So you want to rewrite this as f is equal to x times e to the minus 3x. And then you can let e to the t is 1 plus t squared over 2, etc. Then you replace this t with the quantity minus 3x. Once you've done all that, then you multiply in the x. Okay? Then, so replace t with this, then multiply by t. And there you have it. It will be fine, I promise. Well, I'm sorry, I meant x. Multiply by x. Then you'll be good. Okay, so in your instructions, it will say something like non-zero. Okay, so what does this mean? Okay, I'm just putting up some words on the screen. What does this mean? Sometimes it'll say such and such, like 4 non-zero terms or 4 terms or 7th degree, or sometimes it'll explicitly say go up to x to the 6th. There's all different ways of telling you when to stop. When to stop, okay? And you have to read the directions very carefully because these each mean something different. So for example, let's say sine of x is, let's say I've written this. What can I say? I can say there are 4 terms, or I can say I'm going up to x to the 7th. I'm not lying because that piece is 0. I could have actually what I mean by 4 terms, 4 non-zero terms. So you have to be careful. If I say just 4 terms, in this instance, it's a little bit ambiguous. I could claim that I have the first, okay, there's a constant that's missing, so there's a term here that's 0. This is a term. This is another. I wrote this wrong. This is supposed to be cubed here, and this is 5 to the 5th. What am I doing? I'm mixing sine and cosine. Okay, so I'm going up to x to the 7th. I still haven't lied. I still have 4 non-zero terms. And so I have the constant, the x squared, the x cubed, the x fourth, the x fifth, the x sixth, the x seventh, and the x to the 8th. I could claim I'm going up to x to the 8th because that piece is 0. I could say I have 8 terms depending on who I'm talking to. I could also say I have a 7th or 8th degree polynomial because I have all the terms up to and including 8, but I could claim that I have 9 terms because it goes, let's see, constant and then x squared, x cubed, x to the 4th, x to the 5th, x to the 6th, x to the 7th, x to the 8th, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So I could claim I have 9 terms and a whole bunch of them are 0. It really depends who you're talking to and what the context is. So just be careful. If it says non-zero terms, they don't count unless they're written down. That's the important part. So my preference, and what you're going to see in the homework, is you're going to either count non-zero terms or you're going to be told what degree to go up to. And that's a lot less confusing than just counting the terms and being left to wonder if the 0 ones count or not. Okay, another piece of advice is for 1C, if you're going to get something like, it's 1 over square root of stuff, I want you to write this as stuff to the minus 1/2, and to go ahead and use binomial to get it to work out for you. So that's how you deal with that. Okay, hints for 2A. 2A, you have 1 over 2 plus x. You need a hint for that, so hold on a second. Okay, so what I like to do when I see this is I say, look, if this is supposed to be in terms of x over 2, well, I'd rather have a single letter that represents x over 2, and then as the last thing I do, maybe I'll switch it back. But if it's in terms of this quantity x over 2, then x is equal to 2t, and so I can replace this with 2t, and so then I have 1/2 times 1 plus t, right? And so this thing we can look up. This bit we can look up or rederive, whichever. And then, as a last step, replace t with x over 2. All right, and so I'll let you finish that. It's very similar to what's going to happen in 2b. So the 2b hint is you want to have a plus r squared in terms of r over a. Again, okay, if r over a is the thing you want, just let that equal to t, and then r equals at, then this must equal to at. And so this, you can now pull out 1 over a squared, and you get 1 plus t squared, right? And I'll let you finish also. But the point is, once you can do this, you can see everything in terms of t, and then as your last step you replace t with r over a. It just makes your life easier to think in terms of t, and then your last step is that little clerical step. Okay, and the same kind of thing happens here. If x over a is equal to t, then x equals at, and so you can put this here, a squared, t squared, take the a squared out, and then the a squared cancels with the a, and then you end up with 1 plus, oh wait, the a squared is gone, now you just have a t squared, and then you go about your merry old way. And then you're going to rewrite this as 1 plus t squared to the minus 1/2, and then at the very last step, so you're going to do this first, and then the last step is going to be worrying about last step, is replacing the t with x over a. Okay, so that's the strategy for 2C. Okay, how do you get through Q3, question 3? It's actually a lot of fun, and it's a little bit hard, but try not to use a computer until you think you know the answer. So I'll give you a hint about how you might proceed, and again, you can always use a computer, but please don't do that till the end, because then you just completely ruin the fun of the exercise. Okay, so the different f's we have, I'm going to call this f sub a, is 1 plus sine of x. F sub b is e to the x, and f sub c is, I'm going to just rewrite it this way. Hopefully it'll help you find the derivatives easier. What a mess. Minus 1 over 2. That's what I want. Okay, now what you want to do is sort of fill in this little grid. All right. All right, I'm going to fill in this little grid. You're going to fill it in. I mean, I already did that. You're going to think about what's f prime generically, and then what's f prime at 0, and what's f double prime, what's f double prime at 0, and what's f triple prime, and what's f triple prime at 0. And once you fill in that grid, it should be plenty for you to answer this question. Now, if you're still stuck, then what you're going to do is you're going to go to the next stage. If still stuck, after you have the entire grid that I just gave you, then what you're going to do is you're going to just sketch this out for yourself. F of x equals, and you're going to just dump everything in for each of those equations and fill in your Maclaurin expansion up to just this much. You don't need to go further than this, okay? So you're going to put a plus dot dot dot, but you're not going to actually use any terms beyond that. That's all the terms you need. Now, what you're going to do is calculate at x equals 0.01 for f of a, f of b, and f of c, all your expansions. And that will be enough accuracy for you to tell which function is larger or smaller. And it's not as bad as it sounds. Trust me, go ahead and do it. You'll find out it's not actually difficult. A lot of things in math seem really difficult until you sort of go down the right path and you're like, oh wait, that wasn't as hard as I thought it was going to be. So there's the path. I'm not going to do it all out for you, but I'm just telling you that's the path. And again, you may not even have to do this, because you may actually get the insight once you fill in this grid. You may say, okay, I get it. I understand what's going on. I don't have to do the whole thing out. But if you do, then don't worry about it. Just go ahead and do it, and then it'll all come together for you. Okay, so that is the end of video 31. I hope that all that is helpful to you, and I will be seeing you soon. Bye.